Welcome students. Now we'll see some basic aspects of thermodynamics in this lecture. Consider some gas here. Okay, right? Initially the piston is in this position. Area of cross section of the vessel BA. Okay, that area of cross section of the vessel is nothing but area of cross section of the piston. Initially the piston is in this position. Okay, now what will happen? Suppose say I heat this gas by putting it on a stove. Okay, so I'm giving heat energy to the gas. Okay, gas temperature will keep on increasing. When temperature increases, pressure increases. When pressure inside the gas increases, inside the vessel increases, gas will try to push the piston up. Okay, suppose say piston moves a distance dx because of that excess pressure up to this point. Now what is the work done by the gas? In general, the work done formula is force multiplied by distance. Force into distance we call. Okay. Right now here what is force per, now what do? I'll divide and multiply with area. F by A into S into Al, right, where A is area of cross section of the vessel. Force per unit area is nothing but pressure. Okay, force per unit area is nothing but pressure, right? S into A. What is S? Distance moved by the piston. Okay, distance moved by the piston is dx. So pressure into this A is area of cross section of the piston multiplied by distance moved by the piston is dx. A into dx will give you what? A into dx will give you, right, area into dx will give you the change in volume of the gas. When the gas is doing some work, means gas is pushing the piston up, what is happening? Volume of the gas is increasing. What is the increase in volume or change in volume? Right, area into dx is nothing but change in volume dV. So general expression for work done dW, a small amount of work done dW can always be taken as P into dV. Okay, now thermodynamics, right, deals with two types of works actually, right? One is external work, means, right, external work done by the gas or on the gas. When I push the piston down, I am doing external work on the gas. When the gas pushes the piston up, okay, gas and an external agent like piston, gas is doing external work, we say. Okay, similarly, gas molecules doing work against their own intermolecular attraction forces is known as internal work done by the gas. But most of the times, unless we go into second law of thermodynamics, okay, right, we don't talk about internal work here. We'll talk whatever work I'm talking about throughout thermodynamics chapters, okay, unless until specified, the work is always external work done by the gas only. So wherever dW is there, right, we have to write it as P into dV, where P is pressure of the gas, dV is change in volume. Okay, now we'll go into what is called first law of thermodynamics. First law of thermodynamics. Okay, now this first law of thermodynamics says what? You take some system. Most of the times you will take gaseous system because, right, changes in the variables are apparent. Okay, it becomes easy for us to observe the changes in the variable state variables of the system. So you take some gas inside this cylindrical vessel. Okay, give some heat energy to it. Okay, I'll give some heat energy delta Q. Is a small amount of heat energy given by me to the gas. What happens whenever you are giving heat energy to the gas? Temperature of the gas will increase. I told you, right? Macroscopic property called temperature is microscopically due to the kinetic energy of gas molecules that we have seen in the previous videos. Okay, right? When you are giving heat energy, temperature of the gas is increasing. Temperature of gas is increasing means what? Kinetic energy of the molecules. Okay, momentum of each molecule keeps on increasing. Velocity of each molecule keeps on increasing. Okay, right, when kinetic energy and momentum of the molecules increases, what happens? Gas molecules will try to push the piston upwards. Okay, piston keeps on moving up. Okay, means whenever what you call you are heating a gas, its temperature tends to increase, its pressure also tends to increase, right? When pressure increases, inside pressure is more, right, outside atmospheric pressure is less. So what happens? Volume also tends to increase, means the gas is pushing the piston upwards. Volume of the gas also keeps on increasing. Volume of the gas is increasing means piston is moving up. Who is pushing the piston up? Gas is doing the piston up. Where from the gas is getting energy energy to push the piston up. Gas is doing some work, isn't it? Where from it is getting that energy to do that work? From the heat energy which I am giving. Okay, now first law of thermodynamics says whenever you give a small amount of heat delta Q to a given system, a part of it will be used up in what you call increasing the internal energy of the gas, and the remaining part is used in pushing the piston up or in doing external work. Okay, this is the mathematical statement of first law of thermodynamics. A small amount of heat delta Q given to any system will result in a small part of it will be used up in increasing the internal energy, and the remaining is used in doing external work. Okay, external work delta W we have seen is equal to PdV, so we can write delta Q as du plus PdV also. du plus PdV. This is our first law of thermodynamics mathematical formulation. Okay, now what is du? Already we have seen in the previous videos. Internal energy. Internal energy is the energy possessed by the gas by virtue of its atoms or molecules. Okay, right? Every molecule will have kinetic energy. Every molecule will have potential energy. The total kinetic and potential energies of all the molecules put together is known as internal energy U. Okay, then what is an ideal gas? An ideal gas is one in which there are no intermolecular attraction forces. So internal potential energy will not be there for molecules. So ideal gas molecules will have only kinetic energy. For an ideal gas, internal energy is purely a function of temperature, because only molecular kinetic energy will be existing. Okay, potential energy will not be there because there are no intermolecular attraction forces. Okay, so du is change in internal energy. PdV is the amount of work done. So it's nothing but simply conservation of energy principle. Whatever energy you are giving in the form of heat must be conserved. It should appear in one form or the other. It should be accounted for. Okay, some of the energy is used up in doing external work, in doing increasing internal energy. Remaining is used up in doing external work. Okay, so first law of thermodynamics is a consequence of conservation of energy principle. Conservation of energy principle. Okay, simple statement. What is the significance? See, we have seen in the last video significance of zeroth law. What is significance of zeroth law? It has given us the concept of temperature. Similarly, what is the significance of first law of thermodynamics means earlier days, okay, say 100-150 years back, when scientists were working out on these fundamental principles, they can measure the amount of heat given by them. Delta Q is known to them. Okay, and they can also measure the amount of work done, mechanical work done, external work done by the gas, okay, in pushing the piston up. Delta W is known. Okay, I am giving, suppose say 100 joules of heat energy, 100 joules of energy in the form of heat. Gas is pushing the piston up. I'll measure the amount of work done by the gas. Suppose the gas has done 40 joules of work only. 40 joules of work. Then, right, I am giving delta Q, right, 100 joules. Gas is what you call doing 40 joules. What is happening to the remaining 60 joules? Energy must be conserved. Okay, that 60 joules is not apparent. That 60 joules is not apparent. So they said that 60 joules is used in increasing the internal energy of the gas. Okay, that is, okay, delta Q. Right, minus delta W is something known as change in internal energy. Okay, right, this is apparent. This is also apparent. Work, heat given by me, I can measure. Work done by the gas is apparent, means I can measure. Okay, the difference between these two path functions, this is a path function we have seen. The work is also path function, means work, how much heat will be given or taken depends on the process we use. Okay, process we apply. Amount of work done depends on the path followed. These two are path functions. Difference between these two path functions is a point function. Okay, we have seen internal energy is a point function or state function. Internal energy is a point function or state function. Okay, so right, delta Q is a path function, minus delta W, work done, is also a path function. The difference between them is giving you an what you call a point function called internal energy or change in internal energy. So first law of thermodynamics has given the concept of internal energy. That is the significance of first law of thermodynamics. It has defined what is known as internal energy. Okay, every gas by virtue of its atoms or molecules will possess some energy. called internal energy of the gas. Okay, internal energy different from, suppose you throw that entire vessel with some velocity, entire vessel will acquire some kinetic energy. You lift the entire vessel to some height, entire vessel will have potential energy, but you put that vessel on the ground at rest, it will not have kinetic energy, it will not have potential energy, but by virtue of atoms or molecules it will have some energy. That energy is known as internal energy. So what is happening to the 100 joules of work, 100 joules of energy you are giving, a part of it is used up in doing external work. Remaining 60 joules will be used up in increasing the internal energy, as the total energy is conserved. That is the significance of first law of thermodynamics. Okay, so in general, delta Q equal to du plus delta W you can write, or du plus PdV also we can write. This is the statement of first law of thermodynamics, right? And what is the significance of first law of thermodynamics? It has given the concept of internal energy for a gas. Now we have seen in the previous videos that internal energy for an ideal gas is purely kinetic in nature. It is a function of temperature only, whereas for a real gas it is a function of temperature, pressure and volume. It depends on all factors. Okay, ideal gas equation equation of state for an ideal gas is PV equal to nRT. Okay, equation of state for an ideal gas, PV equal to nRT, where n is number of moles of the gas. Gas constant is 8.314 joule per mole Kelvin. T is absolute temperature. P and V are pressure and volume. This is known as equation of state for an ideal gas. For 1 mole of gas, we take n as equal to 1. Okay, right now, how to apply? What are the applications of this first law of thermodynamics? Okay, applications of first law of thermodynamics will be like this. Applications. Okay, first one, we go for an isothermal process. What is an isothermal? Iso means same, thermal process means, right, the changes are brought about in the system at constant temperature. Isothermal process is a process in which the temperature of the system remains constant. Okay, T remains constant. For an ideal gas, okay, right, internal energy is purely a function of temperature, I told. Okay, when temperature remains constant, kinetic energy of gas molecules remains constant, temperature remains constant, internal energy remains constant. So, right, in an isothermal process, when U remains constant, change in internal energy, du will be equal to 0. Change in internal energy, du will be equal to 0. Therefore, right, what happens to first law of thermodynamics when du equal to 0? Delta Q equal to delta W. Okay, delta Q equal to delta W means all the heat given to the system will get converted into external work. This is an extremely useful point here. Okay, what is a heat engine? Okay, what is a heat engine? A heat engine is a device which converts heat into work. Okay, a device which converts heat into work is known as heat engine. Right now, which type of process is suitable for a heat engine? Okay, if the process in which all the heat given will get used up in doing external work, that becomes the best process for a heat engine. The purpose of heat engine is to convert heat into work. So if I choose a process in which all the heat given gets converted into work, it will be very good, suitable for a heat engine. So this is one process in which we can try to operate a heat engine. We should keep this in mind. Okay, so an isothermal process is suitable for a heat engine. Okay, where entire heat will get converted into work. Now, right now, actually here we have to, before starting this, right, we should see some sign convention. Okay, in first law of thermodynamics, right, applying first law of thermodynamics, we follow some sign convention. Okay, sign convention. Sign convention, what is that? Heat given to the system. Okay, you take any system. Okay, there is some gas inside. Whatever heat delta Q you are giving to the system is taken as positive. Delta Q is equal to positive. Okay, you give 10 joules or 15 joules or 100 calories or whatever it is, right? Whenever calories are given, you should immediately convert that into joules only. First law of thermodynamics, all units should be in work units. Means you cannot take work in joules, what you call internal energy in some, what you call heat given in calories, internal energy some ergs or something like that. All, even if other units are given, every other energy in other units should be converted into joules, SI system, and then apply here, right? Suppose say 10 calories of heat is given to a system, it does 20 joules of work. Okay, you should not put 20 calories and 20 joules of work here. No, convert this 10 calories, right? 1 calorie equal to how much? 1 calorie equal to 4.2 joules. So 10 calories means 10 into 4.2, 42 joules. You have to convert that into and substitute in the formula. Now, the sign convention is heat given to the system usually we take it as positive. Okay, whatever heat that comes out of the system, heat coming out of the system is taken as negative. Delta Q negative. In solving problems, suppose say he says, right, where so and so process is taking place, when system is undergoing some process, 20 joules of heat has come out of the system. You have to take that 20 as minus 20. Okay. In physics, we take heat given to the system as positive and heat coming out of the system as negative. In chemistry, they follow slightly different one. Whatever heat is given to the system, they take it as negative. Heat coming out of the system, they take it as positive. Okay, some small changes are there because the way we look at things in physics, what our requirements are different, right? Chemistry requirements are different. So that a small difference will be there. Don't get confused when you're studying these topics will come in physical chemistry also. Only thing is the sign convention will be slightly opposite there. Okay, right? Heat given to the systems, heat going into the system is always positive. Heat coming out of the system is always negative. Heat rejected by the system, heat lost by the system, heat coming out of the system, negative we say. Similarly, work done by the gas. If the gas pushes the piston up, work is done by the gas. Work done by the gas, delta W is taken as positive. Okay, delta W is taken as positive. Positive work means work is done by the gas. Okay, now if I push the piston downwards, I am doing work on piston, right? Piston is moving downwards. Okay, then that work is negative. Work done on the system. Work done on the system is negative. Work done by the system is positive. Heat given to the system. Heat given to the system is positive, right? Heat given out by the system is negative. Heat given out by the system is negative, right? Next one, whenever internal energy of the gas increases, du is taken as positive. Du is positive. Whenever internal energy of the gas decreases, du is taken as negative. Okay, these are the things which we should keep in mind in applying first law of thermodynamics. Okay, you see whether work is done by the gas or on the gas, whether heat is going into the system or coming out of the system. Okay, a prop is depending on that you have to substitute positive negative values in first law of thermodynamics. Okay, delta Q equal to du plus PdV or delta W. You have to substitute. If work is done on the system is right, PdV you should take it as negative. Okay, internal energy is decreasing, du will be negative. Okay, heat is coming out of the system, dq will be negative, like that. Okay, right, this is known as sign convention. We have to keep this in mind in applying first law of thermodynamics. Right, now again going back to an isothermal process. Okay, we have seen that in an isothermal process temperature remains constant as internal energy is purely a function of temperature. Okay, T is constant means U will be constant, so du equal to 0. So first law of thermodynamics becomes delta Q equal to simply delta W. Both are positive here. Okay, positive delta Q means what? Heat given to the system. Positive delta W means what? Work done by the system. Means in an isothermal process, whatever heat you are giving to the system, whatever heat delta Q are giving to the system will be used by the gas in doing external work. Okay, because anyway internal energy is not changing, right? So all the heat given will be used up as external work. Now put minus sign on both sides. When you put minus sign on both sides, what will happen? Right, negative work means what? Work done on the system. By chance if I push the piston downwards, okay, I am doing some work. Okay, what is happening to that work? That work is rejected as heat energy by the system. Okay, work done on the system minus delta W equal to minus delta Q, that is heat rejected by the system. Means whatever work I do on the system will be, right, rejected by the system as what you call heat energy into the surroundings. Okay, this is the application of first law as far as an isothermal process is concerned. Next one, the next process is an adiabatic process. Okay, adiabatic process. What is an adiabatic process? Adiabatic means not allowing heat to. Means you don't allow any heat to get into the system or any heat to come out of the system. Okay, means the system is maintained under what you call insulating conditions. Okay, right? Adiabatic conditions means, right, we'll take a vessel with insulating walls on all sides, right, such that heat cannot go into the system or come out of the system. So heat given to the system or taken out by the system, delta Q will be 0 in an adiabatic process. Okay, in a reversible adiabatic process, delta Q is equal to 0, right? When delta Q equals 0, first law of thermodynamics becomes what? Delta Q equal to, right, du plus delta W we are writing. Delta Q equals 0 means du equal to minus delta W. Okay, what is the meaning of minus delta W? Work done on the gas. When you push the piston down, what is happening to the work done by you in pushing the piston down? It will be used up. Positive du means what? It will be used up in increasing the internal energy of the gas. Okay, you put that minus sign on this side, it will be minus du equal to delta W, means plus positive delta W means what? Work is done by the gas, right? Without supplying any heat. Suppose say the gas is pushing the piston up. Okay, means gas is doing work, right? Where from gas is getting energy to push the piston up or do that work? Gas will spend its own internal energy because there is no source of heat from outside. Okay, gas will spend its own internal energy and pushes the piston upwards. Okay, when it is spending its own internal energy, what will happen? Internal energy is decreasing means temperature will keep on decreasing. Gas will get cooled down when it pushes the piston up without supplying any, just like we. Okay, we eat some food and we run for 5 kilometers. Without eating food also, sometimes we run 5 kilometers. Okay, then where from we are getting energy to run for 5 kilometers? We are spending our own internal energy. Okay, so our internal energy decreases. In this case, internal energy, the gas decreases means gas will get cooled down. Okay, that is in decrease in internal energy when what you call gas does positive work. So in an adiabatic process, okay, heat given to the system or coming out system is 0 such that du equal to minus delta W. Okay, the next process is an isobaric process. So okay, the next process is third process is isobaric. What happens to first law in an isobaric process? Isobaric process. Okay, isobaric. Iso means same, baric means volume. Okay, isobaric process means constant volume process. Constant volume process means what? You will not allow the piston to move up or down. Okay, right, such that when piston cannot move, you will fix the piston such that it cannot move up or down is not allowed, such that volume of the gas remains constant. Volume of the gas remains constant. Okay, when volume of the gas remains constant, gas cannot push the piston up or you cannot push the piston down, means you cannot do any work on the system or gas cannot do any work on piston. That is, work done by the gas, delta W equal to P into dV. dV is change in volume, V is constant, so delta W will be equal to 0. When delta W equal to 0, what happens to first law? Delta Q equal to simply du. Okay, both are positive here. Positive work means what? Heat given to system. When you give some delta Q amount of heat to a system, right, the entire heat will be used up in increasing the internal energy only, right? All the heat given will be used up in increasing the internal energy. Okay, right? Suppose say you take out some heat from the system. Okay, when you take out some heat from the system, if piston can move, it will come down, but you are not allowing the piston to move up or down, isn't it? So what will happen, right? Where from you are getting this heat energy, gas must be spending its internal energy, right, and pushing out, and what you call it, sending the heat energy out, means what will happen? Internal energy of the gas decreases. Means if you put minus sign here, right, delta Q, minus delta Q, heat coming out of system. How heat can come out of system, right? When internal energy decreases. Okay, so in a reversible isobaric process, we'll see what are reversible and irreversible process. We'll see most of the process we discuss here are reversible process only. Okay, reversible quasi-static process we call. I'll introduce the quasi-static process in the next topic. Okay, right, and reversible process. So in a reversible isobaric process, okay, right, all the heat given will be used up in increasing the internal energy only, because delta W equal to PdV equal to 0. Okay, next process is what is known as isobaric process. Okay, the fourth process is an isobaric process. Isobaric process means a process in which pressure remains constant. Baric means pressure. Okay, so here pressure of the gas remains constant. Pressure is constant. Okay, what is first law statement? First law statement is delta Q equal to du plus PdV. Okay, du plus pdv. Now if I take a process in which I'll be heating the gas or cooling the gas, whatever it is, but I'll see to it that its pressure remains constant. Its temperature may change up or down. Its volume may increase or decrease, doesn't matter, but its pressure should always remain constant, say. Such a process is called an isobaric process. In an isobaric process, what happens to first law of thermodynamics? If there is any dp term here, change in pressure is there. If it is there, it will become zero, but there is no change in pressure. Pressure is there. Pressure is not zero. Pressure is constant, that's all. Volume may increase or decrease. Internal energy may increase or decrease. Temperature may increase or decrease. Okay, so first law of thermodynamics statement remains as it is. Delta Q equal to du plus pdv in an isobaric process. There won't be any change in the equation of first law. Okay, in isobaric process, delta Q equal to du plus pdv only. Okay, the next process we come across is what is known as a cyclic process. Okay, what is called the fifth process is a cyclic process. What is a cyclic process? Okay, cyclic process means, name itself says, you start from some point. The gas is initially at some pressure P1, volume V1, temperature T1. Okay, you will make this gas, you will heat the gas, you will give some heat energy to the gas, you will push the piston down, you do some changes. You will take it to P2, V2, T2. Okay, from P1, V1, T1 by isothermal process or isobaric process or adiabatic process or what you call isobaric process, whatever it is, you will take the gas from initial state P1, V1, T1 to P2, V2, T2 somehow. Okay, we need not bother about. From P2, V2, T2, I'll again make some changes in the system, giving heat, taking heat, doing some work or getting some work done, whatever it is. Okay, I'll take it to a state called P3, V3, T3 like this. Means its pressure, volume, temperature all may change or only if some may change, whatever it is, it will go to a new state. Again from P3, V3, T3, suppose say you bring the gas back to its initial state P1, V1, T1. Means how does the shape of the process look like? It starts from one point, okay, undergoes a series of changes, go to a new state. From there it goes to another new state. From there, if it comes back to its initial state, means gas has started from this point A, okay, went to B, from there it went to C, again it came back to A, say. Means now the pressure, volume, temperature remain P1, V1, T1. Okay, means after, right, you are bringing back the gas to the same state, same initial state, right, after making it undergo a series of some changes. Such a process is called a cyclic process. Such a process is called a cyclic process. So, a cyclic process is one in which the gas is made to undergo a series of changes, and again, after the end of the process, it is brought back to its initial state. Such a process is a cyclic process. Okay, right now, what happens in cyclic process? What happens to first law? Delta Q equal to du plus pdv. What changes will occur? In a cyclic process, I told you internal energy is a point function, just like potential energy. What is the potential energy of this pen at this height, mg h1? I will take the pen to this height, mg h2. Potential energy is mg h2. I will take the pen to here, okay, to this point, mg h3. Potential energy changes. I will take the pen to another position, mg h4. Potential energy changes. Again, I will bring back the pen to initial point. Okay, I made the pen to undergo a series of changes by changing its potential energy, but at the end again I brought the pen back to its initial state. What is its potential energy now? mg h1 only. mg h1. What is a change in internal? So change in potential energy. Change in potential energy is 0. Okay, because right, this you are changing the potential energy, right, and again bring it back to the initial point means what? Its potential energy remains same as before mg h1. So in a cyclic process like this, all point functions, that's the advantage of point functions is what? In a cyclic process, all point functions remain unchanged or they remain same as before. So delta Q, right, du and work done here, this is a path function. Okay, this is a path function. See, in bringing the pen back to its initial point, work done by me is not becoming 0. I am doing some work, isn't it? Okay, because it's small amount of work, I am not noticing how much work I am doing. But suppose you ask me to take it around entire Hyderabad for 10, 50 or half an hour or 1 hour and again bring it back and put it here, I will be doing a lot of amount of work. change in potential energy pen is 0, but work done by me is not 0. Okay, energy spent by me is not becoming 0, means path functions are not becoming 0, but point function will become 0 in a cyclic process. So what is the only point function in first law of thermodynamics equation? Internal energy. U is a point function, so change in internal energy du in this case will be equal to 0. So in first law of thermodynamics, when du equal to 0, right, so what happens to first law? Delta Q equal to, right, delta W. Okay, means all the heat spent, heat given to system are, right, is equal to the work done by the system. Okay, or you do some work on the system, right, all that work will get converted into heat and gets rejected out of the system. Again, here also I am getting delta Q equal to delta W. Where else did we get delta Q equal to delta W? In the very first process called isothermal process also we got same result, delta Q equal to delta W. So in these two processes, delta Q equal to delta W, these two processes are suitable, best suitable for a heat engine. So which process is chosen for a heat engine? It is cyclic process, right? Invariably all heat engines in the world will work in cyclic process only. Okay, right? Now why only cyclic process? Why not only isothermal process? Only isothermal process has some practical disadvantages that will become clear once we go to heat engines like Carnot engine or a petrol engine. Okay, right? So all engines are made to work in cyclic process only, so entire heat gets converted into work. These are the applications of first law of thermodynamics. Okay, we'll continue the remaining topics in next videos. Thank you.